Hi, I'm Dylan. This is Economics Tutoring at Arizona State University. Today we're going to be going over short minimization for producers that use two inputs. So what I've written on the board already is we have our production function, y equals 2k to the alpha times L to the beta. We're going to say that k is going to be our capital input and L is going to be our labor input. And we also have our input costs, WK and WL. I'm going to be leaving them in variable form. Whenever you do a problem, you can go ahead and plug those in whenever you want. I'm going to be doing this math just with the symbols. So the first thing we're going to go over is short-run cost minimization. And so what short-run means is that one of our two variables is going to be held constant. In this case, we're going to make k our constant input. That makes sense because usually the thing that will be constant will be our land input or whatever capital we have. So I'm going to call our constant k value our k bar. So I'll write that up here. Okay. Now the first thing that we want to do when we're doing our cost minimization is we want to actually write our cost function. And so the way we write our cost function is we're going to assume these constant costs. And so what we know is that our cost is going to be equal to our cost of labor times amount of labor plus our cost of capital times amount of capital. So I'm going to go ahead and write WL times L plus WK times K. So since we actually know that our K is going to be constant in this case, we can just replace this K with our K bar. So I'll write that there. Now, normally what we do is we go ahead and set up a Lagrange. But because it's short run and we actually only have one variable that's changing, we can just do a normal first order derivative. So I'm going to go ahead and write out my function here. So what we know is that we have this, but we can actually replace this k with our k bar once again. So we get y equals 2 k bar to the alpha times L to the beta. Now we're interested in getting our L star, which is going to be our optimal amount of labor. So what I can do is, because I only have one variable here, I can just go ahead and isolate for L. So I'm going to go ahead and divide this y by this 2 k bar to the alpha. So and then what I can do is, in order to isolate this L from this B, I have to raise both sides to the 1 over B. So I'll go ahead and do that. And so what will happen is I'll go ahead and I'll get my L equals y over 2k bar to the alpha all over 1 over B. Okay. And this is going to end up being my L star. Okay. And now what I can do is I can go back to my cost function. So I have my L star, and so I'm just going to plug that in for L. So C equals WL times all this plus my WK times my K bar. And so I actually see now that I have my cost with the only variable being my output y. And that's actually all we're looking for with our short run cost minimization. So once you get to this point, you've actually solved it. So as an overview, what we've done here is we assumed that we had one constant input. In this case, it was our K bar. And I was able to plug that into my cost function. Now, since I had that K bar, I was able to plug that into my production function, and from there solve for my L star. Once I had my L star, I just plugged it back into my cost function, and I just had my cost in terms of the only variable there is going to be our output, which is ultimately what we're looking for with cost minimization. So this is how you do short run. If you have any questions, come to the Economics Tutoring Center at Arizona State University. Next time we're going to be doing long run cost minimization. Thank you.